All right, this is a pretty straightforward second law problem. And the second law, as it's commonly written, is that the acceleration of an object can be calculated if you know its force that's being exerted on it divided by its mass. The idea being the larger the force you exert, the greater the acceleration you get. But the more massive it is, the lower the acceleration you get, which makes sense. If you're pushing something that has a lot of mass, it's not going to move very quickly. So this is what I like the second law. I think this makes more sense to think of it this way, but you're commonly going to see it written as F equals ma, and maybe that's the easier way to remember it. So this is just a problem where you know 2 out of 3 of those and you find the third. So you start reading the problem and you identify the variables, just like motion problems. So what force is required? Okay, so we don't know F. To accelerate a 2 kilogram ball, 2 kilograms is a unit of mass, at a rate of 3 meters per second squared, that is the unit of acceleration. So we have all these filled in, and then we just plug into our equation. So we didn't know F, we knew M was 2 kilograms, A was 3 meters per second squared, so you get F equals 6 kilogram meter per second squared, and it turns out that this entire thing, kilogram meter per second squared, can be written as newtons. That's the unit of force. So the force required is 6 newtons. So that's this first problem. Here's a similar problem. Again, we're going to figure out what we know. A 30 kilogram crate, that is the mass of the crate. And we're using a force of 220 newtons. We just do not know the acceleration. So if we say, okay, F equals m times a, we can plug in 220. We can plug in 30. And we're just solving for a, so the best way to do that, we're going to divide each side by 30. So then we're going to get that a equals 220 divided by 30, which will be 7.33, and the units of acceleration are meters per second squared. Now one thing you can do, just to check that real quick, make sure you didn't make a mistake, is go back and use your original equation and say, okay, does 30 times 7.33 equal 220? It does, so it doesn't hurt to check your work really quickly. So this is a very basic problem, plugging in. They do get more complicated, but make sure you can do this before you try to move on. So until next time, I am Derek Genova. Have a delightful day.